So we have seen SAT solvers, and now let's look at how we solve theory constraints. Before getting into theory constraint, let's look at a theory and understand how theories work and how do we solve theory constraints. First example we'll pick is the theory of equality and function symbols, and let's see what it contains. So in this theory, you first need to have a signature, and the signature is set of function symbols. And they are uninterpreted. We don't know what these functions do. They are not like plus and minuses, which have some specific interpretation under the particular theory. However, these are the functions which have no interpretation. That stands for this U. These are the four axioms of this theory. As we have discussed earlier in the lectures, that any theory comes with a set of symbols and the set of axioms. First, we need this theory of equality. How equality behaves is that x is equals to x. This is called reflexivity. If x is equal to y, then y is equal to x. The third axiom is called transitivity, which is x is equal to y and then y equal to z. Then you have x is equal to z. The fourth axiom you may not have seen before is called congruence. What it says is that, let's suppose you have function f which has n parameters, and you can call this function with two different sets of parameters, x1 to xn and y1 to yn. Let's suppose you know that x1 is equal to y1, xn equals to yn. That means both the calls of the function are using same parameters, therefore their output should be the same. That's the basic property of a function. So this is axiom for the uninterpreted functions. We can also include predicates which we have assumed to be not there. However, this can be easily extended. So let's suppose you have these axioms. So how you derive some facts in this theory? These are the proof rules you use. Essentially, if you look at carefully, you will find that these are simply explication of those axioms themselves. But it may not be the case in general. However, these three axioms let you prove anything you may want to prove in the quantifier-free fragment of the uninterpreted functions. Well, let's look at an example. Let's suppose you have this constraint, which is a conjunction of three literals, and you want to check if it is unsatisfiable. And so you can write down a proof using three proof rules. So from y equals to x, you can derive by using symmetry x is equal to 1. Then what you do, you can x is equal to y and y equals to z. Now you can apply transitivity and can derive x is equal to z. Right? Now we carry on, and now we can see that this function call has two parameters each, but the second parameter is same, and the first parameter has been shown to be equal. So therefore I can say that these two calls return the same value. However, our formula says they are not equal, right? So therefore we can derive false. This is the way you prove unsatisfiability using in a proof system. You may ask yourself that is this set of rules, set of axioms is complete? Yes, you can prove that these any conjunction of literals that is unsatisfiable, then there is a proof of unsatisfiability using these three proof rules.